Hello, good evening. Our topic today is applications of the normal distributions. The standard normal distribution curve can be used to solve a wide variety of practical problems such as this. The only requirement is that the variable be normally or approximately normally distributed. Our problem today is the age of the subscribers to certain newspapers are normally distributed with mean of 32.5 years and standard deviation of 4.6 years. What is the probability that the age of a random subscriber is more than 30.5 years? The first thing to do is we're going to solve for the standard normal or the z-score, which z is equal to your x, which is 30.5, minus the mean, which is 32.5, all over the standard deviation, which is 4.6. 30.5 minus 32.5 will give us 2. So here 30.5 minus 32.5 is of course 2, negative 2, divided with 4.6. 4.6. Our z-score is negative 0.43. Negative 0.43. We're going to use only two decimal because in the table we can only use at most two decimal places. On the table of the normal curve, we can only see your z-score less than our answer, which is negative 0.43. On the table here, the standard normal distribution came from the negative z values. So on the left side are negative 3.4 and so on. On the top are 0, 0.1, 0.2 and so on. So we're going to find negative 0.453 is negative 0.4 and the top is 0.43, so the intersection is 3336. So the probability of z less than negative 0.43 is 336. So here is 0.336. But our question is more than 30.5 years. So the probability of z greater than negative 0.43 is you subtract from 100% or from 1, which is 0, 1 minus 0.3336. So our final answer will be 0.6664. If you're going to graph that, the mean was 32.5. 30.5 is on the left side of 32, so 30.5, and it says here more than, so we're going to shade on the right side. So 66.64, or you can say it's 67%. That's a long way of solving a application of normal distribution. Another way of solving that is using the TI-84. In your TI-84, you just press second, 10 bars. Normal CDF will be number 2. The default lower value here, the lower bound is negative E99. But since we're doing greater than, so our lowest value will be 30.5. 30.5. And the upper bound is the positive infinity. Positive infinity in your TI-84 is E99. So that is second, comma, 99. It means that's the positive infinity. Our mean is 32.5 and our standard deviation is 4.6. And the answer is the same. Is 66.81, which is also 67%. Another way of solving that is using the Microsoft Excel using megastat. Megastat is a add-in toolbar in your Microsoft Excel. How to do this is megastat. Click megastat, then probability, and under probability we're going to click normal distribution. Our mean was 32.5. Our standard deviation is 4.6. We're going to calculate the probability given x, and our x was 30.5. And it says they're greater than, so we're going to click the upper bound. We can change this to our x or z value if we want to, and we can do the shading a solid color, or we can do parent. Okay, let's click OK. So here, the mean is 32.5, the x value is 30.5 greater than, so shaded to the right. The area is the same as 0.6681 or 67%. As you can see here, we can use a variety of solutions in solving a problem on application of normal distribution. We can use the tabular way using the formula. We can use the TI-84, and we can use the Microsoft Excel using megastat.